Hello everybody, welcome back again to our mathematics class, which is we are covering the sequences in this video series. Okay, dear students, we talked and we introduced what was the sequence. To having a sequence, we needed to define what was the set. In this video, we are going to cover how many kinds of sequence do we have. Okay, dear students, introduction to sequences. We started and we told you the sequence, the number of sequences was as the strings of the numbers, and also we defined that every n must be from the natural numbers. Okay, dear students, we have two types of sequences. First is finite or infinite, or whatever you pronounce it, finite or infinite. First is the finite and infinite sequences, and we will talk about this one. And the second is monotone sequences. Step by step, we will follow with you these types of sequences. First, how we can define what is the finite and infinite sequences. As you remember, if we have the numbers which doesn't stop in one place, for example, if we have a number like 1, 2, 3, 4, 5, 6, and so on, it doesn't stop in one place. For example, it doesn't stop and it is going forward up to infinity. On the time, that means that is a finite. That is an infinite. When we have an interval to the numbers in the sets, on the time that is called what? Finite. Okay. If a sequence contains a countable number of terms, what does it mean? If we have the terms which we can count that up to 50, up to 60, up to 100, 2000, and so on. For example, if I have the set of the numbers like 1, 2, 3, 4, and up to 10, that is countable because we can count the terms of that sequences. If we cannot have, like this one, the numbers, we cannot count how many terms that the sequence has, and the time we will have an infinite sequence. Let's have some examples. Every time we show or we denote a sequence like among the parentheses, among the brackets, like among the what? Parentheses, like 1, 4, 1, 4, 9, 3 point up to comma up to n square. It means this is infinitely going to forward. It doesn't stop. Sorry, it stopped in the numbers like, for example, 410, for example, 400, for example, and then up to 1000. This kind of sets shows as what? Finite sequences. And the next, we define if we have an infinite number of terms in a sequence, and the term that is called what? Infinite sequences. We will have some examples like which is written a sub n. If you look, that is that we can read this one up a sub n, not a n. A sub n is equal with 1, 4, 9 up to n square, and here look, it doesn't stop up to n square. It is going forward and it doesn't stop. It is going to infinity, and the time it has many terms which we cannot count here, and the term that is called what? Infinite sequences. Okay, dear students, and the second one we have monotone sequences. Monotone sequences, as you studied in the functions sections, we had some functions which was decreasing, which was increasing, which was non-decreasing, which was non-increasing. These are one of the properties, honestly, one of the sequences which we will have, inshallah. Monotone sequences. What is the monotone sequences? Here, when we talk about the monotone sequences, on the time our aim is talking about what? Increasing sequences, decreasing sequences, non-increasing sequences, and non-decreasing sequences. We will have some conditions when we are writing the number of terms of that. On the time we started, it was the first term, it was the second term, it was the third term, up to infinity. If each of the terms of a sequence is greater than the previous term of a sequence, on the term, this kind of sequence is called what? Increasing sequences. Like, if I have a sequence like 1.2, 0.3, it's going up to forward, up to infinity. On the time, look, what does it say? the second term must be greater than the previous term. On that time, that will be what? Increasing sequences, because it is starting from 1, it is going 8, it is going forward, it's going up to infinity. For example, 1, 2. 1 is the first term, the number 2 is the second term here. Second term, as you know, the number 2 is bigger than the number 1. Number 3 is the third term, which is bigger than the number 2. This is the next term, which will bigger than the previous term here. This kind of sequence is called what? Increasing sequences, as we will have a sub n plus 1 is bigger than a n. Okay, the second one, if we have the if any or if each of the term of a sequence is smaller than the previous term, on the term we will have a decreasing sequences. Like if I start this from n up to n minus 1 and it is going 3, 2 up to 1. Like in plus 1 is smaller than in or r sub n. We will have some numerical example for showing this monotone sequence. Like it starts from 10 up to the second term will be 8. The third term is shown in this example is 6, and it's going up to number 1 because the second term is smaller than the first term, and the third term is smaller than the second term. On the term, if you look such as the examples for the sequences on the term, we will say this kind of sequences, call it decreasing sequences. And the third is called non-decreasing. For example, if we have sequences like 1, 1, 2, 3, 4, 5. Here, if we have the second term is equal with the first term, that is called what? Non-decreasing. The second term is equal or smaller than the first term, and the term that is called what? Non-decreasing sequences. And also we will have another another kind for monotone. n plus 1 is bigger or equal with the number n term on the term that is called what? Non-increasing. This is true for both 1, 1, 2, 3, 4 up to infinity, because the first term is equal with the second term. Here we will have non-decreasing what? Sequences. Okay, dear students, we had two kinds of sequences. One was finite and infinite sequences, as you learned. The second was monotone sequences. In monotone sequence, we divide it into 4 parts. Okay, dear students, we will have some examples for this in the next, and also we will solve some one or more than some examples to show how we can show that the given sequences monotone, or which is decreasing, or which is in decreasing. Yes, dear students, according to the conditions which sequence is monotone or not, or increasing, decreasing, non-decreasing, and non-increasing. On the time we will solve some two examples. Okay, prove the sequence with the general term r sub n is equal with n plus 1 over n squared plus 1 is a decreasing monotone sequence or not. On the time to showing or to proving a sequence is given to us that is monotone or in simultaneously that is decreasing or not, we had some conditions. According to the conditions, we studied like n plus 1 for decreasing, it must be less than n. On the time, what does it mean? Instead of every n in the given sequence, on the time we will replace with n plus 1, and the time we will make that this is less than n. Let's check this one. n is equal with n plus 1 over n squared plus 3 plus 1. Here, n plus 1 is equal with n plus 1 plus 1, and the time instead of n plus 1 square plus 1. Here we will have n plus 2, n square plus 2 times n plus 2. This is n plus 1. Is this term which we found after substitute instead of n plus 1, is this smaller than n or not. Here, let's check. N plus 2 over n squared plus 2 times n plus 2 must be less than, to be decreasing, n plus 1 over n squared plus 1. To show this is true for the theorem or for the condition which we said, we must substitute number 1, because we said the every sequences is defined in the natural numbers. When I substitute n is equal with number 1 on the time, n plus 2 will be number 3. And also n square, 1 square plus 2 times 1 plus 2 will be n square on the time, 2 plus 2 will be 4, 4 plus 1 will be 5. That is 1 plus 1 is equal with 2 over 1 square is equal with 1, 1 plus 1 is equal number 2. As you see here, 3 over 5 is less than when I divide number 2 by number 2, the final result will be number 1. As we see, 3 over 5 is a quotient number which is less than 1, and the given sequence is decreasing. That is true for the sequence. Okay, let's check the second example. Prove the sequence Rn is equal with n plus 1 over n squared minus 5 is a monotone sequence or not. To proving what the given sequence is monotone or not, on the time we must check for n is equal with number 1. If I have n is equal with number 1, on the time E1 will be, this is the first term. 1 plus 1 is equal with 2 over 1 square is equal with number 1 minus 5 will be 2 over negative 4 is equal with what? Negative 1 over 2. When n is equal with number 2, on the time the second term will be 2 plus 1 is equal number 3. 2 squared is equal with what? 4. 4 minus 5 will be negative 1. This is equal with negative 3. The second term is equal with the negative 3. If I have n is equal with number 3, on the time the third term will be 3 plus 1 will be 4. 3 squared is equal with 9. 9 minus 5 will be 4. 9 minus 5 will be 4. It is equal with number 1. Let's check. We said if a sequence is monotone on that time, it must be increase, decrease, or non-increase, or non-decrease. Let's check this one. A1 is equal with negative 1 over 2. A2, the second term, is equal with negative 3. And the third term is equal with number 1. Here, let's check. A1 is bigger than A2. And here, A2 is less than A3. For this reason, it cannot be, because the conditions which we must have for the monotone sequence on the time, it doesn't follow. For this reason, the sequence is given to us is what? Non-monotone sequence. Because we said to having a monotone sequences, it must be decreasing completely, it must be increasing, non-decreasing, non-increasing. For this reason, it cannot choose as any non-monotone sequences. Okay, dear students, if you have any problem, if you face any problem about the topics of this video, please comment us. We will reply in a soon time. Thank you for your watching.